Hi friends, in this video I will show you how to use application class data sharing with Spring Boot applications. Application class data sharing, or AppCDS, is a JVM feature that reads and parses a set of system classes and application classes and stores this data in an archive. Then, upon application startup, the JVM reads the data from the archive, and it is faster than loading the classes from scratch, so the startup is faster. Application class data sharing is compatible with all applications, you don't have to change anything in your application code, and it is very simple to use. Plus, you can use AppCDS with ahead-of-time processing, which is supported by Spring, and that will reduce the startup even more. I will show you how to use AppCDS and AOT processing on a local machine and in containers. And we will Dockerize our application using two approaches, with a Docker file and build packs. Ready? Let's get going! For this tutorial, you will need a Spring Boot application. I will use a reference Spring Pet Clinic application. You can get it on GitHub. You will also need Docker, so make sure the engine is up and running. Let's start with creating an archive on a local machine. As I already mentioned, you don't need to change anything in your application code. But as we will use AppCDS with AOT processing, we need to enable it in the Maven plugin configuration. Alright, let's open the terminal. I'm using Liberica JDK 23 for this tutorial. As for Spring Boot, the version should be at least 3.3. First, create an executable jar with the Maven clean package. Let's see how fast the application starts without AppCDS and AOT. Run it with the standard java jar command. As you can see, it took almost 4 seconds for the application to start. So the next step is to create an archive. But we will not use the executable jar. The Spring team recommends using an exploded jar in production, as it is more efficient. So let's unpack the executable jar. You will need the djarmod tools extract option for that. And we now have a new directory with the lib subdirectory and the jar file. It's time to create the archive. For that, we need to run the application with the following options. dspring AOT enabled tells that we want to use AOT processing. Archive classes at exit tells the VM that we want to create a CDS archive located in the root directory of our project and named application.jsa. dspring context exit on refresh makes the application exit automatically after it has started. And finally, we are pointing to our exploded jar. You can see now the CDS logs specifying the classes that didn't get into the archive. Not all classes get into the archive, we should understand that. For instance, classes from older JDK versions are not archived. But anyway, most classes do get into the archive, so no worries. Let's check whether the archive was created. Yes, here it is. Now, let's run the application again. This time, we will again use dspring AOT enabled option, and as for the archive, we will now use the shared archive file option and point to the archive. And we use the exploded jar again. The application started in less than 2 seconds, which is about 40% improvement over the initial result. It's time to enable AppCDS in a container. Let's first look at how we can do that with a Docker file. Keep the AOT processing go, it is required for containers also. And here's the Docker file we will use. At the first stage, we are using Liberica runtime container based on Liberica JDK Lite and small Alpaca Linux. At this stage, we copy our project into the image and build it with a standard Maven clean package command. At the second stage, we also use Liberica runtime container. We copy the executable jar from the first stage and extract it into layers using djarmod tools extract layers. This layout helps to accelerate the updates of Docker images. The most frequently updated layers are placed on top, and when they are changed, the bottom layers are pulled from the cache. At the next stage, we use Liberica runtime container with a prepackaged CDS archive for JVM classes. We copy all the resulting layers from the previous stage to this final image. We also run the following command when the container image is built. We use the dspring AOT enabled option, the archive classes at exit option to create the archive inside the container, the dspring context exit on refresh option to make the application start and exit in the container so that the JVM could create the archive. And finally, we use the jar launcher that knows how to work with layered jars. Let's look at the entry point. When we start our container image, it is started with the following options: AOT enabled, shared archive file, and jar launcher. Build the container image with the usual docker build command. Now, let's check our image. Here it is. It takes 287 megabytes, which is a bit more than with the usual container image. But the image is still very small thanks to Liberica Runtime Container that provides a small base image for Java applications. You can package PetClinic with the base image you usually use and compare the results. Let's first run the container image with the PetClinic without AppSeries and AOT to see how fast it starts. As you can see, I already have the PetClinic standard container, so we are going to use that. And we are using the usual docker run command. The application started in a bit more than 4 seconds. Now, it's time to check our container with AppSeries. The command is the same, so I'm just changing the name of the image. The application started in less than 3 seconds. You can also build a container image with AppSeries and AOT enabled using build packs. It is even more convenient because build packs automatically create the layered jar. To enable CDS and AOT support in build packs, let's add a configuration to the Maven plugin. Configuration, image, totally optional, but let's give a custom name to our image. Say PetClinic CDS build packs. Now, env to add environmental variables. First, BP Spring AOT enabled. Set it to true. Then, BP JVM CDS enabled. Also set to true. The order of variables doesn't matter, of course. Cool! This is all we need to use AppCDS and AOT with build packs. The command for building a container image with build packs is super simple. All you need to do is run Maven Spring Boot build image. The build process has finished. Let's check our image. Here it is, PetClinic CDS build packs. It takes 538 megabytes. This is because build packs use Ubuntu under the hood, so the image will be bigger. But in Spring Boot 3.4, build packs use Ubuntu Gemi Tiny for running the application, so the image should be smaller. Okay, let's run our image with the usual docker run command. As you can see, the application started in a bit more than 2 seconds, meaning that we did everything correctly and AppCDS and AOT worked. In this video, we looked into using AOT processing and AppCDS with Spring Boot applications. Don't forget to like, subscribe, and until next time!